Okay. Says we're live. People who are watching the recording, hang out for a minute. Let Jerry and the thing hang out while we just get some links posted and make sure that YouTube's not lying to us about it being live.
Those liars.
Yeah.
Can you guys hear me?
Yeah. Hey,
Yeah.
Jerry.
Hey, Jerry.
Is it noisy in the background?
No, can't hear it at all.
Oh, okay, that's perfect then.
Yeah, that is good. That is good. Well, yeah, so let me get this started. I'll do the agenda. I got a couple things on the agenda, and then I'll turn it over to you, Jerry. So let me share my screen. Well, first of all, I'll get this started. Welcome, everybody, to the Permissionless Software Foundation Technical Steering Committee meeting. Today is Wednesday, June 28th. I am Chris Troutner. I founded the PSF. I also operate fullstack.cash, which is cloud infrastructure for blockchains, as well as freelance software development. Let's go and do a quick round of introductions. Aaron Shoemaker, you want to introduce yourself?
Yeah, Aaron Shoemaker, a member of the PSF for a long time now. I'm going to take Sunman's line here. Big favor of permissionless, big fan of permissionless software. So he's not here to say it, so I got to say it today. Yeah, that's working on scheduling and other stuff and other blockchain related stuff right now. So
nice. Go ahead and introduce yourself, Stoyan.
Yeah, I'm not Aaron. So yeah, one of the not Aarons in the PSF. And yeah, my name is Stoyan, and I'm helping with some of the JavaScript libraries for the foundation. So for me.
Nice. Yeah, Jerry, if you have a minute, go ahead and introduce yourself.
Yeah, thanks, Chris. My name is Jerry. I'm not currently in the PSF Foundation, but I have worked with the BCH wallets that Chris has built for quite a long time now, and yeah, just happy to share what I built at East Waterloo this week, for this past week.
Nice. Nice. Yeah. Okay. So I'm going to share my screen and we'll go over the agenda. So as always, our agendas are filed on GitHub under the Permissionless Software Foundation group in a repository called TSC for Technical Steering Committee. We file them as issues. This is issue number 57. The scope of the meetings covers these subjects. It's going to be a pretty short agenda today. I just got a couple quick updates, and then I'm going to turn it over to Jerry, and he's going to give us an talk through this hackathon submission that he submitted for ETH Global, which is a swap between Bitcoin Cash and an EVM chain using on-chain script. So pretty interesting stuff. I just a couple things on the agenda I wanted to get to before we get to that, though. Local Trade List is this app that I've been working on. It's intended to help neighbors trade with neighbors. It leverages our pay-to-write database. All the data here is sort of censorship resistant. So I've done some updates. So the map, because this is map-based and it's intended for people to zoom in on where they are located, to find the vendors that are in their area, it now remembers the zoom setting. So for every person who uses this app, they'll get like their own custom experience. So this is my general area. So I'm going to zoom in here and look at these stores that are on the map. But wherever you are, when you zoom into your local area, the next time you come back and visit this, the app will remember what your zoom settings were. So it'll automatically load you right to the area that you're interested in. You don't have to start at a zoomed out. So I thought that was a cool, easy feature to add. And I've also added some documentation. This is at docs.localtradelist.com. And so I've just got some written documentation on how to create a store with screenshots. And I'm going to create some videos to complement that, and hopefully start getting more vendors adding stuff. I'm most of the vendors that are in here I've added myself. I'm going around and collecting like local local farmers and people in my local geographic area that I want to trade with. So I'm just sort of proactively adding them to the map. So that's local trade list. And another thing I'm working on currently is this image uploader. There's a back end and a front end component to it. And this will let people upload images to our IPFS pinning cluster that runs on top of the Pay-to-Write database. So just a very simple app to let you upload an image there, because that's needed for these store owners that are creating stores on the map. And it's just sort of a general thing, and it'll promote the usage of our pinning cluster if we have just a really nice, easy user interface for people to upload an image to pin to the pinning cluster. Well, with that, that's the agenda. Jerry, let's go ahead and explore your hackathon submission. I've got these 2 links here, and I'll share these in the Telegram channel. Hackathon page, and go to the code repository as well. All right, well, Jerry, with that, go ahead and take it away and walk us through your hackathon project just at a high level. Like, what does it do? Why is it valuable?
Yeah, absolutely. So as you guys can kind of see, it's basically trying to do cross-chain swaps between Bitcoin Cash and essentially any sort of EVM compatible chain. Just, it's just basically Solidity files doing escrows on both chains. I was also taking advantage of some of the bounties that they had there. So one of them was called Ethereum Attestation Service, EAS. And after talking with the guys there at the hackathon, it basically just sounded like, writing up a kind of like a schema, so kind of like a JSON file, and then just signing it on both parties, and then storing it on their smart contracts that they've deployed on all these networks. Unfortunately, they didn't have Polygon support as of yet, nor do they have Bitcoin Cash, obviously. So instead of relying on their smart contracts, I was just basically doing all the attestations with off returns and locking these funds appropriately. So yeah, the idea, again, lock up the funds on both sides on Bitcoin Cash. You can basically just go to the GitHub code right now, but essentially it's just using cash scripts to escrow all the funds. And essentially, in order to release it, there's either a expiry timeout. So, basically it's checking the block time and whatnot. Or if you want to go through with the exchange, then both parties will have to sign. It will be kind of like a 2 of 2 multi-sig in that case. I also had a bit of extra code that I more or less commented out, but it was essentially trying to take advantage of the covenants that's in Bitcoin Cash to actually enforce, like both parties when they do the exchange portion, they also have to submit their proofs and whatnot, or something along those lines, so that the contract itself can actually enforce the swap transactions rather than just hoping that they'll set it up manually themselves. So I didn't get to that part at this hackathon, but I had it documented in there, so on and so forth. And I also mentioned, I believe it was on the submission page, that there was also this other lit protocol that was supposed to do cross-chain key management. So coordinating keys and whatnot. If you have smart contracts in one, you can control it from other chains with their keys and all that kind of stuff. So again, they haven't as of yet supported it, but they are definitely open to all these kinds of non-EVM chain supports. And so the team's obviously very small, so just trying to be patient with them. But yeah, on the very, very high level, that's basically kind of the idea, right? You lock up the funds on contracts on both sides with an appropriate, timeouts. That's very, very similar. And then you just have to either go through the approval, both parties will have to do that signage, or you just, withdraw the money. And yeah, so that's basically.
So in a previous meeting, we covered libauth and cache script and that sort of the escrow contract that was used by local.bitcoin.com. So I'm familiar with that idea of using object data sig to essentially lock funds in. So a buyer and a sell in that case, there's a buyer, a seller, and an arbiter. And so the buyer, or let's see, the seller, no, the buyer locks funds into the escrow. The seller does their thing, and then if the buyer's satisfied, then they release the funds to the seller. If there is a, and that's essentially a 2 of 3 multi-sig essentially. And then if there's a discrepancy or or a dispute, then the arbiter can get involved and decide. They can be that second key of the 2 of 3 determine who gets the funds. So that's the frame of reference I'm coming from here with this. So I get that you're locking funds in this escrow on the BCH side, and then there's a time lock. So if things don't happen and after a period of time, you can unlock the funds. I like that. That's a nice safety feature. So and then you said that there is an op return, attestation goes in the op return, and then how does the EVM side of things interact or how does the EVM contract and the BCH contract, how do they communicate or interact with one another?
Yeah, so currently right now there's no direct way of communication. The way I kind of set it up is so that so you can actually just go into the contract files if you want, just scroll up a little bit. But essentially, it will be like 2 pairs of keys that are already like pre-known, and they'll be doing both the signage and whatnot, like creating that message and approving it on both sides. So this will be the Solidity file here, and yeah, you can see the recipient. I haven't figured out how to actually get the to do all this swap in one step. Right now, I've just set a approve boolean to actually have the owner approve it. And once it's approved, they can't change it and whatnot. The recipient can just withdraw, as long as, of course, it's set to approve. But on the Bitcoin Cash side, which should be in the cash script folder, that's where I was putting in a lot of the other stuff, like the attestation data, blah, blah, blah.
Okay.
Yeah, so swap law. So that would be the main contract there. And so yeah, the withdrawal function is just the timeout. The demo purpose one is just a way for me to actually interact with the contract. It's just checked off on it. But the main exchange function is again just a basic 2 of 2 kind of multi-sig. And then here down below where I see the attest function, that's where I was basically trying to put in all of the locks and just enforce it with all the covenants and the introspection stuff.
Okay. So on the EVM side, it looks like there's an owner, so that would be the owner of, say, the ETH, the recipient, so the person who's going to receive the ETH. So they approve it on the ETH side to release it, and then it looks like it's the same thing on the Bitcoin Cash side. There's a sender and a receiver. Am I getting that right? And that basically
So I believe the data structure for this is also in here. I believe it should be in the source folder or so, and it should be a signed data. Sign message.
Sign message.
Yeah, so the sign message right there is the JSON data that I'm creating. So this is where the attestation service, they create all the schemas. And then what they do is they'll have 2 contracts. One smart contract to register all these schemas, another one to actually do the attestations. So here again, I was just hacking the schema structure itself. All the relevant addresses, all this kind of stuff. If both sides again sign it and approve, and the messages are exactly the same, then we're assuming that they're approving it. And the main thing that the guys at the EAS service mentioned was that the main thing was that both parties actually do sign and show on chain that they did agree at one point. If they backstab or go back on the word or something like that, you can always go into further dispute afterwards, right? But here again, it's just just to sign and prove that both parties did actually agree to this certain action.
Yeah. So the actual action of signing and approving on the EVM side, is that a contract interaction? They're just interacting with the smart contract and submitting something?
Correct. So on the smart contract side, they'll just like submit it to their relevant contract address, and then just like do all that interactions there. Now, obviously, on the smart contract side, they have a lot more functionalities like revoke, like all these kinds of things. But yeah, this basically right here. I mean, the schema itself can be used for all these other things like voting, like tallying things and stuff like that. I was just using this for facilitating the swaps, so that you can see that two parties on two chains actually did coordinate and agree on this schema.
So then on the Bitcoin Cash side, I'm assuming the buyer and the seller, they put the signature information into an op return and broadcast a transaction, but then how does the contract interact with that?
Sorry, the contract interact with the what?
With like the data in the op return, or at least
okay.
Yeah, walk me through how the funds get released on the Bitcoin Cash side.
Yeah, so the first step would actually be to make an op return attestation from the cash script address, right? So the cash script address, and I think if you again just go back to the source folder, there should be a call somewhere in there to actually generate that op. I think it should be cashscript.js.
Okay.
And it should be a line that is commented out actually. So if you just keep scrolling down, scroll down. Okay, so right above there at the very last, the demo purpose call. So yeah, you can see the op return 60. So I was basically making some a customized metadata for op return. So 60 would is supposed to represent the chain ID and stuff like that.
Okay.
And then the other one is kind of like the network ID for the various EVM chains. So then it follows the Alice sign message and the Bob sign message. So that first gets published, and then once the smart contract, the cash script contract makes the op return call saying that hey, both parties did sign, then on the Ethereum side, the owner can go ahead and approve, and then start that kind of like swap process.
Okay. Yeah, I'm still a little foggy on the I'm familiar with on Bitcoin Cash with a script. You can generate like a pay to script hash address and you can send funds to it. But then I'm still a little foggy on how that contract then interacts with an op return. Is there like an introspection call that does that?
Yeah. So in the cash script file, the very first line where it had all the bytes, creating the bytes and whatnot. Sorry, the cash script file for lock swap. Lock. Yeah.
Swap lock.
Yeah. This one right here. Yeah. So if you go down to where I commented the stuff out, at the very bottom. Yeah, so right there it says bytes op return data, right?
Okay.
So that's creating the op return, and then right below, I believe it's third require. So third require, second one it just says the value of the first output has to be 0, which makes sense for op return. And then the second one just says this has to be the exact op return data that this one's saying.
Oh, okay. Interesting. Okay, yeah, this is great. This is where my knowledge starts to drop off. I need to dig into the cash script and how it does this level of introspection.
Yeah, they have similar introspection calls for tokens, but with the UTXOs and whatnot, it's just a little bit like iffy to work with. But yeah.
Very cool. Well, this is exciting to me because I mean, I know that the ultimate demonstration is to be able to swap tokens on Bitcoin Cash for tokens on an EVM chain, but I like the fact that this could be used with the base currency to easily exchange Bitcoin Cash for, say, Avalanche or Bitcoin Cash for Ethereum and just do a swap for the base currency across two chains.
Yeah, with the like honestly on the Bitcoin Cash side, even if you're swapping SLP tokens, it's not that hard, right? Because you're just literally just generating all these transactions fairly manually. Whereas with the EVM, sorry, with the smart contracts, they have a lot of these like ERC20 contract that's basically already pre-built for you. And then if you want to do the customization, you need to actually go in the code. Whether the code allows you or not, that's a different story, right? But it's a lot more steps that you have to work with.
Yeah, yeah. Oh, very cool. Very cool. Stoyan or Aaron, do either of you guys have any questions about any of this?
Not yet. I just need to look a little on the code. Maybe on the next meeting.
Yeah, likewise. I'm gonna have to re-watch this recording and go through the code and try and understand. I mean, I'm really curious about the limitations of or how this could be automated, say in a production, because there'd also have to be a user interface. And so, Jerry, am I understanding it correctly that like you basically you'd lock funds on both chains, and then you'd probably do the Bitcoin Cash side first, and say the person with funds on the EVM chain would wait for essentially a transaction that would notify them on the Bitcoin Cash chain, and then they would be safe to release the funds on the EVM chain. Am I getting that workflow correct?
Yeah, like right now, this entire process is very, very manual. So it has to be done, kind of like that kind of order. But the idea is, you definitely want to automate it. What kind of interface? I haven't really, decided on like what the best one is, because you can definitely imagine like if you had like a wallet, then you wouldn't. This would just basically be like a protocol, right? If you were to design your own, then yeah, obviously you need to have like the front end and stuff like that. But yeah, the idea here is that if this can be done and in somewhat like in some sort of like an SDK or something like that, then yeah, it can be just kind of like like local Bitcoin trading where people are just listing up their trade offers, and whoever pairs it up can just like go through with their creation, blah blah blah. And this way, you don't also have to worry about any sort of liquidity provider issues, right? It's all just pure matchmaking.
Yeah.
Yeah, just straight across. That's nice.
I'm starting to see how that can happen. So it is very manual. When the funds hit the wallet, we've secured both the funds, and then when the one fund hits the wallet with the EVM, then we manually transfer, or is the smart contract like using some sort of oracle to monitor that wallet? I didn't get that part.
Yeah, so you're going to need some sort of oracle or indexer or some sort of way to read it. But the nice thing is that like you don't need to rely on one centralized oracle to do so, right? Anyone can just read the other chain and just do their own validation.
Yeah, so I'm getting the sense that it's similar to like the escrow system that I built for SLP tokens, in that both the seller and the buyer have to be online. Like you can't just like post it and then have a buyer. Like, seller can't just post it and then the buyer can come and buy it whenever they want. Like, there'd be a third step involved where the seller would recognize that there is a buyer exists and wants to buy it, and then they would have to sign something and broadcast it to finalize the actual trade.
Yeah, it's very similar to that, I guess. Except maybe like I don't think you need both parties to actually be online for this. Because like as long as you just have the signature templates and the public private keys that you want, then you can just call it up or anything like that, right?
So it could
like,
be
you don't
automated.
need the person to be actively listening, like
Yeah. Okay, interesting.
Yeah, so again, this probably like most likely there will be a lot more things, and probably a lot of bugs and whatnot. But during the manual process, you can definitely achieve some sort of swap with proofs of both parties agreeing to to the whole thing. So
Mhm.
again, that was kind of like the whole point of the Ethereum attestation service to begin with. So just basically trying to emulate what they're doing, but using the Bitcoin Cash tech stack.
Yeah, okay. That makes sense. Yeah, I really like this, man. There's a few things in here that I've never seen before, like particularly just the op return attestation. I haven't played with that. So I'm looking forward to digging through the code and checking that out a little further, and then I'm definitely starting to get more into EVM smart contract programming. So this looks like a simple, nice program for me to read through and practice on.
Yeah. I mean, again, the nice thing about the op returns is that the signed message are like 64 bytes. So I was basically just putting in both of the signatures on there, as you kind of saw, plus the extra metadata code, kind of like SLP or memo.cache or something like that.
Mhm.
So there's plenty of space, left to go, right? You could probably fit in a little bit more afterwards.
Yeah, exactly.
And yeah, so yeah, that's the correct website, attest.sh. That's the correct one.
Cool. Well, that is awesome, Jerry. Good work. And thanks for giving us a little something to think about. Do you have any plans to continue the development of it after? Was this just for the hackathon, or are you gonna roll this into a product for something?
I mean, yeah, definitely. We'll try to work on not just the swap part, but also the attestation. The EAS team was reaching out, it's like, what are my future plans? It's like, definitely want to integrate it, stuff like that. But yeah, like for the swap part, it's something that I know, like you mentioned, a few other people had mentioned. So just getting some sort of proof of concept, even if I don't like finish it off on myself, could just be like inspiration for other people to just take a look at, right?
Yeah, exactly. Just seeing that's how I really value people, especially when it comes to like libauth and cache script. Like I really need to see a real application doing some real thing. Like I'm not good at just like abstractly studying it and trying to like understand like the cryptography without any sort of direct application for it. So it really helps me to study code like this to grasp it.
Chris, if you want, I can also share with you the fork of the Badger wallet that we had worked on a few years prior, where we integrated cache script contracts. So you can kind of see, like on a user interface, what that would more or less look like.
Nice.
I
Well, yeah,
can send it
maybe
to
I'll
you
take you up on that. Yeah, that's cool, man. Well, I know that there's some talk about there's a Telegram channel, native, I think it's Native Wallet, and so they're looking at ways to do that, and they're taking a really like so you might want to share that in that channel, because I know they've got there's been some discussion about ways that Ethereum does things that they don't like and how they'd like to do it differently in a wallet, and that's where a lot of this discussion on the trade-offs is happening.
Yeah, well, unfortunately, Ethereum does a lot of things that are very, very questionable on the programming design side. But no, like even for what's it called, the for libauth, right? It's like Jason was messaging me. It's like, hey, there's like this React Native WebAssembly library that can help you convert to all this stuff. It's like, I am not good enough as a developer to know what the hell's going on here.
Yeah, the WebAssembly compilation seems to throw a curveball to a lot of people.
Yeah, because CapScript back in version 0.3, was still using Bitbox and a bit of PSF stuff, I believe.
Okay.
But yeah, afterwards Roscoe switched to libauth, and it's like, yeah, things just stopped working on native afterwards, React Native.
Oh, that sucks. I didn't realize that. Well, cool, man. Thank you for the demo and the explanation. Let's move on to Stoyan. You were talking about the near blockchain and ways to basically encapsulate blobs of JavaScript. And I wanted to learn more about that. I should have screen sharing turned on. Oh, and actually, yeah, there we go. One other thing I want to show is the Bitcoin payment module. I'll do that after Stoyan's done.
Okay, I will try to be short. Can you see my screen? Or
Yeah.
Yep.
so it's more like a concept, which is interesting. What they're trying to achieve is a decentralized front ends. If you remember, before these SIA guys, they was doing something like this one.
Mhm.
So this they call this like blockchain operating system, and it contains of three like main components. Okay, parts, because one is named components. So three parts. So these components, it's like you can think about it like a small contracts, smart contracts, which are saved on chain. So, but they're like here is the example one. So they're like some mix of like CSS and JavaScript code.
Hmm.
So you save this thing on chain, and you can fork it, and it will create your own contract. So you can own this thing. You
Hmm.
can just get somebody's, like this guy Matt, contract, fork it, and it will be my contract. So
Oh, you
I
know
will
what?
own it.
We're looking at your desktop. Are you?
Oh.
Should we be looking at a different screen?
Okay. Maybe I made a mistake. Let me try again. Desktop 2. Maybe it's the right one. This one?
Yeah, there we go. Canto. We're looking at the web browser. Cantopia.
Okay. So the main site maybe when you can go is this boss.gg. And yeah, this whole idea contains like three parts, and these components something like a piece of like JavaScript, like this one,
Okay.
where you can call directly ether.js, and you can put some CSS there, but you save this on chain, so it's preserved there. It's immutable, but you can fork it, so you have your own copy, and
Okay.
and you can send some parameters to this guy, which is interesting. So you can have the same contract, but when you send it some like parameters, it will do something, and with other parameters do something else.
Well, yeah. So, at what point does the execution happen? Like,
Yeah,
so-
okay. So the other component is named gateways. So everybody can create gateway, and there's several of them already working, like this boss GG something. The purpose of these gateways is to execute these contracts. And the
Mm,
interesting part is that you can have your own gateway, which will execute these contracts in some way, and somebody else can have another gateway. Like, for example, he can ignore the CSS and just use the JavaScript, and it will looks different.
okay.
So
Okay.
yeah, the gate, and you can run this gateway on your own machine for development purposes. So if you
Yeah.
download contract, execute it on your machine, and yeah, and this is maybe the whole thing. You can see a lot of tutorials. They have even like a Lido component ready here.
Mm,
So with just one or two clicks, you can have like this Lido site,
Hmm.
or you can use directly ethers.js from this component. So you can do a lot of already stuff that you're doing in your regular JavaScript.
Interesting.
So yeah, and you can go to some of these gateways, and you can very easy just copy somebody created components. So there was the Uniswap component. You just copy it, and you can customize it. So yeah,
Mhm.
interesting idea. I'm not sure
Yeah.
how
Yeah, this is an interesting idea because like I could see like with our SLP tokens and the mutable data, we could do the same thing where you could take a blob of JavaScript and upload it
Yeah,
as the mutable data for a token. And then but then the execution, this is an interesting idea with the gateway,
yeah.
particularly the selective execution, how you might get a different output from a different gateway. Have you seen any examples of people using these for applications or games or something
Yeah,
commercial?
you can see this near dots social. It's like something like I don't know, Twitter, but I don't know, something like social network. So
Hmm.
there's a lot of you can connect with people here, and you can get their components. This everything is in fact component. This my profile is in fact component.
Mm.
So when you create like a profile in this near social, you're doing the same thing. You're just forking some contract and
Hmm.
customizing it.
Wow.
So this is one of the maybe main example in this well, all of these
Okay.
example gateways.
They're all different gateways.
So yeah, this is what I wanted to show. I'm not sure,
Yeah.
but I'm not sure how is this work for them to save so much information on the blockchain.
Yeah.
In fact, this in here you're paying for your storage, so it's not like you're saving this for free.
Hmm.
You're paying for storage, but it will pretty much fill the network with some JavaScript.
Yeah.
So
I was looking at
it's
the near and how to run full node, and they have three different classes of full node. There's the archival full node, the RPC full node, and a validator full node.
yeah,
And so depending on which you're trying to do, and I think that's there, it's all to do with scale. So it's like if you're just trying to interact with the network, you don't necessarily need all the data. You don't need an archival node. If you're just trying to be a validator, and I noticed Avalanche is doing the same thing where you can run, and Ethereum same thing where you can run a pruned node as a validator, so you really don't need very much of a footprint in terms of uh hard drive size to run a validator, but it also, that node's not really good for anything other than validation. And
yeah.
then there's the archival node that has all the data. And yeah, so it's an interesting way to approach scaling, because there is that problem that blockchains have in the sense that they just grow and grow and grow, and they never
Yeah.
get any smaller.
Interesting. They're trying to be the middleman because you're saving the components on near these JavaScript blobs. But as you can see here, you can in fact work with other blockchains. You can just get the code from the near, and using this ether.js, you can work in fact on the Polygon. Just
Wow.
the JavaScript will be there
Yeah,
on near the code.
right.
So yeah,
That's
they're
interesting.
trying.
Oh yeah, and I just wanted to mention if you go to ETH Global Waterloo websites, Near was actually a sponsor there, and they have all these showcases. So yeah, actually, if you just go to a showcase, you should see all the different projects being listed. But they
Yeah,
also
yeah,
had a lot of people working on Near as well.
they have EVM compatible like shard from many not many years, but from several years, Aurora. So they always presenting on these Ethereum like events. So yeah, interesting.
Yeah.
This is all from me. So if you can talk about the module, I can
Okay.
stop sharing
Yeah,
here.
go for it. Yeah, that's pretty interesting. And this notion that you had of like storing the data on near, but then accessing it from another blockchain, just as a general trend, this seems to be the trend, is that all these EVM chains are trying to figure out how to interact with one another. And there's no really clear standard yet. Like Avalanche has their subnets, Polkadot has something similar. Near is just like put everything here, and then there's bridging, and bridging can be many different things. And so there's no like real clear trends as to like what is going to be the standard way to do it in the future.
Yeah, but this Zero Labs guy, they are doing a pretty nice job with this layer 0, because
Yeah.
they're putting the standard there.
Yeah.
You can exchange between blockchains in the standard format, just messages, and you can use these messages for what you want, for bridging or for just like communication.
Yeah, have you seen layer 0 used for communication type stuff, or is it mostly just for moving coins and tokens?
Pretty much everybody is using them now to make like multi-chain tokens. Like I think the USDC
Right.
is now like using layer 0.
Yeah, they're using,
And
and I
for
guess if you can move a
communication-
token across the chain, then the token can
Yeah.
point to data elsewhere.
But it will be interesting to use it not only for this one, just for sending messages like these signatures now we are talking about. You can send maybe signatures between the blockchains like messages.
Mm-hmm. Mm-hmm. Yeah, so I'm excited for this sort of these cross-chain standards to settle down, because I think the next step after that is scaling. Like right now, it's impractical for a normal person to run an archival node for any of these EVM chains, and so maybe that won't be a problem. Like that may just not be a problem for the market. That might be totally acceptable. And I'm just curious, like in 10 years from now, there's going to be both a standard way to do cross-chain transfers, but then there's also going to be like a lot of these EVM chains are going to be so bloated. I'm keeping an eye on things like Mina, where they throw out all the data and it's all ZK, and the whole blockchain is always like under 200 kilobytes in size, but they give up a lot of it. Like, it's running an archival node is sort of a thankless thing. But there might be a way to do smart contracts that just have the state of the contract and don't need to reference any data outside of the smart contract state. So all these different ways of doing it. I mean, I think ultimately the goal is to have fast, scalable data that can cross chains. But the devil's in the details. Getting there. So it's fascinating to me to see all these different ideas being explored right now.
Yeah, I think the main thing is that obviously, as you kind of mentioned, EVM is quite bloated and whatnot. I had a lot of opportunity having a chat, this past weekend, with a lot of the Ethereum people, and they're like, well, first of all, they're always shocked as to why I'm even doing anything on Bitcoin Cash, because they just thought it was like completely not. It was just like a cash system, right? They didn't know any of the other tooling stuff.
Mm-hmm.
But even then, it's like I really do feel like there's a lot more people that's actually kind of interested in the UTXO models. We can kind of see like Ordinals and BRC20 being hated by maxis, but the Ethereum people absolutely love it, right? It's like, oh my god, you can actually do this for relatively cheaply. And honestly, for Bitcoin Cash and stuff like that, we definitely need to put in a bit more effort into like getting some sort of interoperability with all the EVM chains, right?
Yeah, and I think tokens is the key to that. And it's interesting, those conversations that you have with EVM people, the thing that they never talk about, or at least like I never get a good response from, is like I can run a archival full node for Bitcoin Cash on a Raspberry Pi, and I can put it in a little tiny box and I can power it with a little tiny battery. And that's and like I have yet to see an EVM chain that can do that. But when you talk to developers, they don't want to think about infrastructure. They just want to code, and they want somebody else to handle that. And that's somebody else's problem. And so that's why it's never really a good conversation.
I mean, here's a really funny thing, right? So when Vitalik was speaking both on Thursday, where they had like a conference summit, and on Friday evening, where it's like the hackathon kickoff, both times he mentioned three things as like he really wanted to see in Ethereum. And I was just sitting back there, was like just laughing to myself. All three of them have already been done on Bitcoin Cash. So
Yeah.
the first one was account abstraction. So like having wallets be part of the contracts.
Mhm,
It's like, well, that's basically smart contract. Sorry, cash scripts right there, right?
mhm.
You had all these attestation services, which again is just writing the opcodes as you kind of saw it through my demo. And then the last part was, like all these on-chain social media. And it's like, when did Memo.cash get developed? Like 2019? And it's still
Yeah, it
being
was
used.
right after the fork.
Yeah. And it's like they were saying, yeah, oh, it's too expensive to run all this thing. Guys, look at some other chains. Look at some
Yeah.
other people, right? So stop being nasty.
Yeah, or at least get inspiration. Like I'm kind of thinking like the ideal blockchain hasn't been created yet. Like I think that a lot of these V1 and V3, V2 and V3 blockchains, like there will be a V4, not a layer 4, but a version of like I kind of consider Avex to be like a V3 blockchain in the sense that it looked at what Bitcoin did right, it looked at what Ethereum did right, and then it tried to do some new things. And they weren't all successful. And so yeah, I'm kind of thinking like this is why I'm keeping an eye on things like Mina and PegNet. Like those are not going to succeed, but there's interesting ideas there that probably will succeed in another form. And
Yeah, I mean, it's similar with me and Cardano. Like I don't really follow and develop too much on Cardano, but
mhm.
just seeing how they still use the extended UTXOs and attaching some sort of smart contracts, it's like, you don't necessarily need to have like the right evolution and whatnot. You can still have different tech converge onto the same points.
Yeah, exactly.
Last week there was interesting tweet from I think Gabriel Cardona.
Oh yeah, Cardano, Gabriel Cardona.
Yeah, about the integrating their like avalanche.js with the Z shell. It was interesting. Did you see this one?
I did not see that. I'll have to look for it.
It's interesting. I need to read it again, but from my understanding, so you have your commands on the shell level. You don't need to do anything like special. Like you can withdraw something from the command line or send from the command line, which is pretty exciting, I think.
Well, it's just a command line wallet, right? I mean,
Yeah,
what's the
but
difference?
yeah, but it's integrated now with Z shell. He created
Cool.
some like a module. So I was thinking, will this work with bch.js with the
I'm
minimal?
sure it probably would. I mean, I know Gabriel's always been a fan of ZSH, or Z Shell, and so yeah, it would make sense that he would integrate a command line wallet into that.
Yeah. So it's
Sorry about that.
let's see, nice step in the more users if they just can send and receive on command line will be like.
Oh yeah. Well, that's why I've always put so much emphasis on like our command line wallet, because if you're a dev, especially if you're like a system administrator, like you're already operating in a command line wallet, and that's the ultimate inconvenience and flexibility. Especially you can just get in there and hack on it and do whatever you need. Well, just to wrap up, guys, I wanted to show this payment module. I'm actually going to turn off my virtual background since that seems to mess with this thing. So this is from Aaron over at Bitcoin Collab, and this is it's a Bitcoin Cash powered relay. So I know we're all familiar with it, but anybody who's not, I just want to sort of bring him up to speed. He's not. I don't think he's on the verge of selling these. So if you ask really nicely, you might be able to buy one. But it's the blue thing is a relay. And then the green thing is a 3-pin connector. So that's the output of the relay. So it doesn't really care what you connect to. So it could be a light bulb, it could be a chicken feeder, it could be a kegerator, it could be, anything that has an on-off switch, this thing can work for. So the little screen is used to display a QR code, and it works over Wi-Fi. So rather than, this thing doesn't have its own wallet, you just tell it an address that you want it to monitor, and you set a price. So anytime that address receives a transaction that is at the price or higher, so like I set this for 3 cents. So anytime the address that it's monitoring receives 3 cents or more, this thing will react and turn the relay on for a few seconds. And so I haven't gotten all the hardware specs on this thing yet, but it's got its own independent battery power. It's got a USB-C connector, which is another way to power it. It's got an SD card reader, and then it's got one switch on the bottom, and then it's got Wi-Fi. It's got a Wi-Fi antenna. So what's cool about this is the first time it powers up, it displays a QR code, and you scan that QR code, and that tells your phone how it acts like its own Wi-Fi hotspot. So it tells your phone how to connect to it over Wi-Fi. You connect to it over Wi-Fi, and you give it the information for your local Wi-Fi router so that it can connect to the Wi-Fi and connect to the internet. And you give it your account information on their dashboard website. And so then when this reboots, it then connects your Wi-Fi and registers with the dashboard. And then you can remotely control this thing over the dashboard. You can see how much money's come in. You can see how many transactions have come in. And this thing just starts working. And because it needs Wi-Fi in order to monitor that Bitcoin Cash address and react to payments. But I built an e-commerce store for him when he's ready to start selling these things. I know they're getting close to using that, but I'm planning on doing a clubhouse here, and I really want to do a Bitcoin Cash powered kegerator. I want to be able to pay Bitcoin Cash and then have the relay turn on a solenoid that then fills up your pint glass with beer. And I've got to get that all tuned in. But eventually that's what I'd like to do with this thing.
And all this came because he didn't have change for the laundromat, but he had Bitcoin Cash.
That was his original vision.
If you know the story.
Yeah.
He went to do laundry and he's like, I don't have change, but I have Bitcoin Cash. Why can I not use my Bitcoin Cash to do laundry right now?
Yeah. 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 So he's been working on it for a long time, a lot of hard work. I mean, for a couple years now, at least. And I know that this is like, I don't even think it's the third version. I think it's like the 7th or 8th version. Like, I don't know how many versions he's gone through, but it's been a lot. And so it's neat to see. This isn't the final product, but it's getting close to the final product, and it really is pretty slick. Especially having gone through with the app.
Just out of curiosity, are you able to hook this up to a jukebox?
Hook it up to what?
To a jukebox.
Oh,
yeah,
sure. Yeah, it's only on off right now. It's not like there's no. I mean, I'm sure there is a way to communicate data, but yeah, right now it's just a relay for on off, but there should be more sophisticated ways to interact with it.
What is the single processor which is based on, like Arduino type?
Yeah, I believe it's an Arduino
programmed.
Or
like,
no, what is it? MSP32? It's like one of those dirt cheap microcontrollers.
Okay.
It might be Arduino or it might be I remember he was kind of going over both of them. I don't have enough light here really to see which one it is. That's a good question. But yeah, I know it's not like an ARM processor. It's a more low level microcontroller.
Yeah, microcontroller, but I mean, if it's something like Arduino based, you can reprogram it later, just connect it via USB to some computer and use this Arduino IDE and maybe make some changes.
Yeah, I'm curious to see if he releases the firmware as open source and if he encourages people to do that, or if he wants to, I don't have any opinion on that. I mean, it's up to him on how he wants to do his business model, but it would be cool to be able to easily reflash these things.
It is a pretty cool step though. And, to what Jerry was saying about the EVM guys, a lot of things, I noticed the same things too. Most of their solutions are not UTXO based. It's just like, let me find another EVM chain. And it's not working on Ethereum. Let's find another EVM chain to work on, and we'll work on that. And there's just a lot of solutions in the UTXO space, especially Bitcoin Cash, for anybody that's looking to dev that direction.
Yeah,
Yeah,
that's
I mean,
Okay.
go
sorry,
ahead, guys.
I just wanted to interject, but I know Pat's from mainnet JS or .cache was working on a Wallet Connect 2 implementation, which
Yeah,
is what a lot of these wallets are basically using. They're all basically using it at this point. But there seems to be a process to like implement, so like that may be like worth out to first at least take a look at. Like first step, before even tokens, quite honestly, you should get the keys and the all that kind of stuff, at least coordinating and talking with each other.
yeah, I'm curious to look into Pat's Wallet Connect work. He just made an announcement this morning I saw about, I think, having a first version of that.
From what I was looking at it, it seems like he was more or less just like trying to hack access to it.
Mhm.
Because the formal process is like you're supposed to make a GitHub issue with all the specs for whatever chain, right? And
Mhm.
I was looking up, like Cardano already had their stuff on there, so
Hmm.
they should be able to support all these UTXO stuff, anyways, right? It's
Hmm.
just like the RPC endpoints and all the chain specs.
Interesting. Do you know, Jerry, about Cardano, like how difficult it is to run a full node? Does it require some serious hardware, or is it something you can do on a normal desktop PC?
Yeah, I've never actually done it myself, but I am in touch with the people at the foundation who could, just point me to those resources.
Okay, interesting. Yeah, I might have to. I haven't really explored that chain as much as I wish I had.
Yeah, yeah. Unfortunately, I spent time investigating too many chains.
Yeah, it does seem like you can just have a career just looking at different chains if it paid.
Yeah, true.
Okay, guys, well, let's go ahead and wrap it up. Any final thoughts before we call it a day?
A lot of stuff to look over.
Yeah, this was an exploratory meeting. So yeah, appreciate your guys' time. Lots of good food for thought here in this meeting. Lots of good ideas and fun toys to play with.
Yeah.
All right. Sounds good, guys.
All right, cheers, guys. Jerry, thank you for the demo. Stoyan, thank you for the demo. You guys have a great